Hey everybody, I just wanted to talk to you about how you're going to be looking at and processing the data that we generated for lab on Thursday. Again, I apologize. I don't know what was going on with that Excel sheet. Had some formatting issues. So what I did was I basically made a whole new one, and I'm going to post that on Blackboard for you guys. Okay, so let's talk about what's in it and what you guys need to do with it. So just as a review, we take your absorbances and then we are converting those absorbances into an actual amount of p-nitrophenol, right? So p-nitrophenol is the chemical that results when our enzyme breaks down our substrate that we put in there, and that's what gives it the yellow color. So basically, the more yellow color, the more p-nitrophenol. So what we can do is we can go in and we can put known amounts of p-nitrophenol into our spectrophotometers and measure how much absorbance there is. Right, so 410 nanometers. So we've got nanomoles of nitrophenol that we've added, and so what it does is we can put in, for some reason, 12.5. That tells us that the absorbance is 0.21. If there's 25, it's 0.42, etc. So what we can do is anytime we get an absorbance, we can basically, we could look on this graph and say, okay, at 0.6, there is about 35 millimoles of nitrophenol. All right, we can see it very precisely if we take the slope of the line, all right, and basically what we're doing is our absorbance would be X, and that would give us our Y-intercept. All right? So that's the math that we're using when we took your original absorbance to turn it into a concentration of p-nitrophenol. All right, so let's look at some example data. Now, this is sort of idealized data, looking at pH 5 and pH 7. So you can think of this as what you should have seen when we went through and did the experiment. And what you can see just looking at it, all right, we graphed it in a couple of different ways. The red line here is the amount of p-nitrophenol at pH 7 and each time period. And then this one is the amount of p-nitrophenol or the rate of production. No, this is just amount produced per minute. Oh, per minute, so it is a rate. So the amount, so this is the rate of production. So how much is being produced per minute at every time point. Now, line graphs, usually what we're trying to show is that we're looking at a continuous, like that we were taking data continuously. So line graphs are showing a trend over time. In this case, because we're doing a timed series, we can get away with it because we're saying that that time series is just snapshots of that continuous line, basically. But what we can see is that our pH 5 overall has a much higher level of activity. It's producing more nitrophenol, p-nitrophenol per minute than our pH 7, right? And from what we know about this enzyme, that's how things should have worked. Keep looking at my picture instead of there. Making eye contact with you guys. There we go. And then this is just the same data that is set up in bar graph form, right? So they're both conveying pretty much the same thing, showing that pretty much across the board, you've got a higher average production of p-nitrophenol at the pH 5. Ooh, okay, so let's take a look at some of your data. So what I've done is I've taken your class data, and basically what this is, and I forget what the colors were. I think it was green and yellow. So this would be green, green group, yellow group, I think red, and I can't remember if we have pink or blue. All right, so each of the four groups is here. What I've done is for each time period, so if you remember, we got these, there's no zero because and there's no, we've got these by subtracting how much nitrophenol there was in the second time period. So minute 1 is we subtracted minute 1 from minute 0, and then on and on. Okay. So that's looking at how much is produced per minute in each of those. Yeah. I'm wondering about our math there. Anyway. So then what I did with that, so each group generated we've got their amount of p-nitrophenol produced per minute, and then I averaged the two together, right, to give us a single column of the average amount of p-nitrophenol in nanomoles produced every minute. All right. Did the same thing with the other two groups for the pH 7. And so what we can do with that is, what we did is we generated an average amount of p-nitrophenol per minute for both of these. Then we can take the average of all those and generate an average for each of those. So we can go ahead and do equal sign, do our average, and then select our column. All right. It wants to average this column here, but we need to make sure and tell it that it's this column that we want to average. All right. And so that's what we do. Let's see the average overall of both. Oops. What happened there? And then we generate the standard deviation by, again, equals. We do stdev here, and then we're going to go ahead and look at the standard deviation of each of those. Now, we can't do the just plus and move over, because then it would take the standard deviation of this column. It would only move it over one. So we need to go in and type it each time. So we're making sure we're getting the standard deviation of the correct column. That'll be important later. Your t-test. So remember, we did this in class, but let's run through it again. So we're going to go over here, and t-test will show up, or you'll have to go to more functions and search for it. So if you just put, oh, there's t-test there, but you can type in t-test. Go ahead and go through that. So remember, array 1 is the first set of numbers you want to look at. Array 2 is the second set of numbers you want to look at. So we're looking at these average columns. Tails, we're going to go with two-tailed distribution. Right? We're going to assume it's on that, that sort of classic bell curve. And then we're also going to assume that they have equal variance. So we're going to go with 2 as far as the type. Now, if you're not sure about that, generally 3 is the way to go with in this square. So when in doubt, use number 3, but we're going to go ahead with number 2. And so that tells us 0.674. If you remember that, I guess it's not on here. If you remember, what we're looking at is our p-value. Right, the critical value is 0.05. If you are less than 0.05, then your alternate hypothesis is real, and that there is a difference between your two columns of numbers. If it is more than 0.05, which this one is way more than 0.05, that means that the null hypothesis is true and that there's no difference between your two columns. All right, so even though there seems to be a difference here, statistically there's no difference between our two pHs, right, in their activity level. All right, so that's the t-test. We can also take a look at and do one of those graphs. So if we go up here and search and then a line or area chart, let's do the one with these guys. And we're going to have to, I'm just going to eat this. We're going to go back and start. We're going to be looking at this. All right. And then I'm going to try it. So we'll have it. We'll highlight this for now. And then we're going to insert and outline graph. Okay. Now, a few things we can do. We can, we go ahead here, get rid of the chart title, get rid of the grid lines. Okay. So what we're seeing is that you know, we're seeing a negative number here because for some reason we had a very low negative to start out in that first one, it looks like, and then we had a level of activity and it dropped down. We had a good level of activity there. So I feel like this number and maybe this number are really dragging it down. We're maybe not seeing what we're supposed to. All right, but in order to be scientifically rigorous, we need to leave that stuff in. We need to add in axis titles. All right, so this axis is going to be small n, nanomoles of P nitrophenol per minute. All right, and then this axis would be So what we want to do is we also want to select our data. Right? So we can either right click on there or I think we can go on, can we do it under design? Or is it under format? No, but you can also do it here. You can also select your series here. Down here it says select data, but the easiest way is you do command click or right click on the graph itself. Okay. So we got our horizontal ones. We want to add another series on here, and I'm going to skip the series name. We're going to get rid of that little extra in there, and we're going to highlight the values for our other column over here. All right, go ahead and hit OK, and hit OK. And so there is our pH 7. We should also clear up what color is each. So let's go back to select data again. We'll select series 1, we'll hit edit. The series name will come up here and just click on the average P nitro per minute pH 5. And we'll do, and we'll edit the other one, average P nitro for pH 7. Right, same thing. We're just adding in the series names. And then now it should, maybe we've got to add data labels. Nope. Legend. There we go. We got to go back in here and chart elements and add our legend. And let's put it on the bottom so it looks a little better. There we go. So this is showing us that the blue is the P nitro pH 5, the red is pH 7. All right, so that's enough for now. And so what we're going to do is I will post another video and we will talk about your averages and standard deviations and setting up one more graph. All right, so I'll see you guys in a little bit.